Okay, now these are homework problems for exercise 9.1. I've been emailed to say that there's people are having problems with question 11 and question 13. Now, with question 11a, it says show that e to the x equals sine x plus 3 has a root between x equals 1 and x equals 2. To do this, we start with e to the x equals sine x plus 3, but we cannot. Remember, if you're trying to solve that, to find roots, you need to take everything over to the left-hand side first, put it equal to 0, okay? Now, so you cannot substitute into it like that. Like, remember, this would be, for example, y equals e to the x and y equals sine x plus 3. If you were to sketch them both and find the point of intersection, that would be the solution of this equation. So when you're given something like this and asked to solve it, you just take everything over to the left-hand side, put it equal to 0, and then you try and solve. Now, because now e is just a number, e is actually 2.7 something. Okay, it's just like pi, it's just an irrational number. And we've got a 3 here. Now, when we're using sine in this sort of context, we don't use sine in degrees mode. It has to be in radians mode. Now, you're probably not aware of this yet because we haven't done the topic trig functions. But if you can see on the calculator here, I'm in degrees mode. You can just see that there. So if I press my degrees button once, I get into radians mode. Okay, so I'm in radians mode now. So you have to make sure it says RAD for radians. When we do the topic on trigonometric functions, you'll understand why. You've already seen some radians anyway when we know that, unless I've just done that with extension 2, I think. So look, just for these questions with any trig functions in them and other functions as well, you must be in radians mode. So just make sure your calculator is in radians mode. So I'm just going to write here, put calculator in radians mode. And so now let's substitute. So when x is 1, what do we get for this function? We get e to the 1 minus sine of 1 minus 3, and we see what we get for that. So just on the calculator, you will go e. Now e is this button, it's the orange bit on top of the ln function. So it's basically the inverse of the ln function. So we go shift e to the x, that gives me e to the power of 1. So we've got e to the 1 minus sine 1, and I think we've got minus 3, and we get negative 1.12. So we write that in. And then we'll also substitute when x is 2, doing the same thing. So we go e, so we've got e to the 2 minus sine 2 minus 3 equals. So we've got e, so shift log, so e to the 2 minus sine 2 minus 3. And we get equals 3.48 approximately. So it's approximately equal to positive 3.48. So because the function of 1 is less than 0 and the function of 2 is greater than 0, therefore a root lies between x is 1 and x is 2. So that's part A. Show that e to the x, which is equal to sine x plus 3, has a root between x equals 1 and x equals 2. Part B says to use the method of halving the interval 3 times to find a closer root approximation to the root. So let's halve the interval once. So we'll do function of 1.5. So 1 plus 2 over 2 is 1.5. So the function of 1.5 is equal to e to the 1.5 minus sine of 1.5 minus, or take away 3. Sine of 1.5 take away 3. And you can, I'll just pause the video while I work that out. And I think you should be fine from here to work the rest of it out, okay? As long as you're in radians mode, okay? So pause the video, finish it off, and then you can restart the video to check. Here's our first approximation. Okay, so you should probably write that the first approximation, 1 plus 2 over 2 is 1.5. So the function of 1.5, I'm getting positive 0.48. Now, because the function of 1.5 is positive, and we'll look back and see what the function of 2 is. See, the function of 2 is positive as well, so we can't use that. But the function of 1 is negative, so we'll compare it with that one. So because the function of 1.5 is positive and the function of 1 is negative, the root lies between 1 and 1.5. Now for our second approximation, we'll look at halfway between 1 and 1.5. We'll be looking at function of 1.25, okay, because that's halfway between 1 and 1.5. You can work that out on your calculator. So you've got e to the 1.25 minus sine of 1.25, take away 3, and I get, so we've got e to the 1.25 minus sine of 1.25, take away 3, I'm getting negative 0.46, okay? And so as the function of 1.25 is negative, now let's see which one's positive. Is the function of 1 positive or is the function of 1.5 positive? Well, the function of 1.5 is positive, okay? So as the function of 1.25 is positive and the function of is negative, and the function of 1.5 is positive, therefore the root lies between 1.25 and 1.5. So that's 2 approximations, okay? So now for our third approximation. So remember, we're using the method of halving the interval 3 times. So our third approximation, that would be the average of 1.25 and 1.5. So you can just do that on your calculator. 1.25 plus 1.5 divided by 2. We want the function of 1.375. Now that's equal to e to the 1.375 minus sine of 1.375, take away 3. And you will get e to the 1.375 minus sine of 1.375, take away 3. I'm getting negative 0.026. I'll make it negative 0.03 because that's approximate. So therefore, as function of 1.375 is less than 0, and the function of, now we've got to see, is function of 1.5 or function of 1.25 positive, because this one's negative. Well, the function of 1.5 is positive. The root lies between 1.375, or x is 1.375, and 1.5. But the root is closer to, which of these two values is closer to 0? Well, the function of 1.375 is negative 0.03, but the function of 1.5, I have to come back and find it, is positive 0.48. That's the function of 1.5. So therefore the root is closer to x is 1.375. Okay? Okay, that's because 0.03 is closer to 0 than 0.48. Okay? As, I'll just put 0.03 is less than 0.48. Okay? And that's the end of that question there, question 11. I'll just put that down there. For exercise 9.1, question 13, I think it'll just be the same problem as there was with question 11. Just please make sure that you are in radians mode. And if you're in radians mode, one of these answers will be positive and the other one will be negative, and you'll just be halving the interval twice to find an estimate of the root. So I'm not going to do that one. I'm sure that you won't have problems with that now. Okay?